I'm recording on this computer. So, hey, Sandra, any teacher giving you a computer ever in your life? You see? I'm giving away that little small computer to him. What are you going to use that computer for? Tell everybody. Music. I thought you were going to program on it. Music. What? All right. It's a small little, I wouldn't call it a desktop. I would call it like, what's the correct name for that? It's called a MAME. A MAME computer. MAME. MAME. All right, so there we go. Now I want to talk about this question, a few things about it. Part A is substitution, pure substitution. But part B is like a slightly more complicated substitution. Because there's two parts to it, and it's important that we kind of discuss it. Let me go ahead and start writing on here. I don't know why my so look at part B. It says here f of x, and I want that out. F of x equals 7x minus 4. So for part B, it says f of x equals to 10. What does that mean exactly? There you go. 10 equals 7x minus 4. This is not to be confused. Not to be confused with f of 10. Gentlemen in the back, I'm not gonna lie to you. I'm really annoyed because I am imparting upon you some knowledge. So, like that. So similarly, you would do C like that, and D the same way. Just, for instance, C is just if f of x equals to x, then you have x equals to 7x minus 4, and you're done. And in D, if you have f of x equals to f of 37, then what you do is you say 7x minus 4 must equal 7 times 37 minus 4. You can tell what x equals. X is just 37 there, but if you want to go ahead and solve it, then you solve it. Does that make sense?
Yeah.
Okay. No, I mean, it's obvious. It's obvious.
Yeah.
Obvious. But I want to discuss this because, again, we have different skill levels in the class. It's true. But at the end of the day, whatever skill levels you do have, that doesn't matter, because what matters is that that you're trying your best. All right, so we're back here. And now if we continue with this section here, it says, look at number 2. It says here, find the two values of x for which f of x equals to 4. F of 4, sorry. And so that is a little bit more interesting. Don't you think? Like if I gave you this question now, and let's go ahead and copy and paste it onto the whiteboard. Where's the whiteboard here? Oh my gosh. Okay, let's find it. Where's the whiteboard? I didn't close it. Where's the rest of my stuff? Wonderful. I can't find my whiteboard. Let me see. The whiteboard should be here. All right, where's whiteboard? Does anybody know where my whiteboard would be? There, wait, no. There you go. It should, there you go. It's just, for some reason, I don't see it here. So let me just start taking stuff off. Unpin this. Maybe it gets a little bit more space, and let's unpin something else here. Of course, let's unpin. No, I want to unpin you. I want you out of my, we don't use you. All right, so now it should appear here. Okay, so let's go ahead and paste this question here. Let's say I asked you this question on Friday. How on earth would you solve that question? The function f is defined by f of x equals x squared minus 3x plus 5. How would you solve it? So first you would substitute 4, correct. Let me zoom in there a little bit because it's a little bit too far away. F of 4. So we got F of 4 here, super simple. 4 squared minus 3x plus 5. So you have F of 4, that's a 4, pretend, let me not be lazy. Equals 16 minus 3 times 4. Minus 12 plus 5. So that's 4 plus 5. It's 9. So evidently F of 4 equals to 9. So now, for what two values will you get 9 there? Okay. So the way you got to do this is, it says here, find the two values of x for which F of x equals F of 4. So if you put 4 squared here, minus 3x plus 5, you get 9, right? So when would that happen again? So let's try negative 4. So let's try negative 4. So this is called inspection, not inspection. This is called trial and error. I can't help but seeing that you're eating popcorn. I thought about it briefly in my mind. You know, that's pretty funny. Oh, it doesn't work with negative 4. So then you want to try another one? Let's try 0. If it's 0, it's 5. So 0 is not good enough. Let's try negative 1. So we have 1 plus 3 plus 5. That's 9. So there you go. For x equals to 4 and x equals to negative 1, you have the same value for F of 4. Yeah. Well, we already had 1. Yeah. Which is 4. Right? Make sense? That's it. You're done. Got it? Yeah. Yeah? I just want to chill. I mean, when I go back, these phones have gotten too big. There was a time when the phones were much smaller. Question, concerns, wonderful people? Yes. Yes. Yep. So, oh no. All right, so let's see any questions here about domain and range that we have. But they don't even work on it that much, honestly. They don't even on this exercise, this section here. If I say it because I should be looking here. So here, this is 3E. When we go down here, let's see if we find one that talks about domain and range. And everything they have here, they have nothing about domain and range. Nothing. So apparently they don't care. You see? And that's the dilemma I have with this, because on one hand, they talked a lot about it, but on the other hand, they didn't really do anything. Okay, so let's do this. Let's look at questions here which look interesting, but they are really not. For instance, if I give you this one, and I know I haven't targeted this too much, but we're reviewing. All right, so say I give you that one. How would you begin to solve that one? Find a point of intersections of the curve. So didn't we do that in chapter 1? Yes. Yeah. Does y equal to y? Oh, yeah. So let's do it. So does x squared minus 7x plus 5 equal to, and I'm gonna write it in this way, negative x squared plus 2x plus 1. Is that true? I just wrote it differently. Yay or nay? Yay. So how do you solve this? Plus x squared plus x squared. And you have 2x squared minus 7x plus 5 equal to 2x plus 1. And you have to subtract 2x and subtract 2x. And then you have 2x squared minus 9x plus 5 equals to 1. And then you have 2x squared minus 9x plus 4 equals to 0. Huh. What on earth are we supposed to do with that? You have 2x squared minus 9x plus 4 equals to 0. You could factor. You use quadratic formula, yeah. Oh yeah. Oh, sorry. I thought you said quadratic formula. I don't know. Can we factor? Do you remember how to factor? Okay, so this is the way I remember factoring. So what's 2 times 4? 8. And then we go. We gotta get a -9, right? So we'll -1 and -8 work. Yes, it works because -1 times -8 is +8, but -1 plus -8 is -9. So now watch me. 2x squared minus 8x plus -x plus 4 equal to 0. Do you see that? Then I can make this into 2 little groups. 2x squared minus 8x plus -x plus 4 equal to 0. So this is going to be 2x times x minus 4. And then my job is to make the other side also have an x minus 4 in there. So I'm going to factor out a -1 times x minus 4. And so now both of these are same. I can say 2x minus 1 times x minus 4, and I'm done. Well, I'm not done, but now I can see the two values. X equals to half and x equals to 4. The way I did it when I was your age and in college is I kind of went, oh, 2x. This is how, oh wait, this is how I did it. I went 2x, x, and I go, well, how many ways can I do this? And I would just kind of like try and see which one worked out. That's what I would do. And then obviously the only one that works out is this one. Because you need to FOIL and then you'll get -8, negative x, and then +4. I know it's tough. I know some of you are unhappy with this. It's not satisfactory. I get it. I understand. However, doesn't matter. Yes. You can. Yeah, do it that way. However, it's important to know that this is the official sanctioned way. Yeah, but sometimes you can't see it. Sometimes sometimes it won't be as easy as that. Huh? Yes, it's called grouping. It's called grouping. Yes. Be careful. All right, so we found both values. You can check it, make sure you got it right, but the way you check it is you substitute half into each one of them and they got to get the same y. So then they ask again, find a point of intersections of this other one. Find a coordinates, a point at which the line meets the curve. They have a few questions here, which, you know, we should discuss. Let's take a look at the one that, number 5. I think number 5 is interesting. This is the same thing as number 4. Guys, let's do number 6 then. If you can do number 6, then you can do number 5. Guys, the likelihood that I'm gonna put something difficult for you next test is probably low. I want to just get you back to basics, and we'll discuss domain and range very soon. But we gotta do quadratic soon enough. So here we go. Here's number 6. There you have, it says find the coordinates of the equation at which the line 3x plus y minus 2 equals 0 meets the curve y equals that 4x minus 3. So you can imagine that. I mean, guys, one way you could do this is by graphing, but we're not gonna graph. So here we have our line. It meets where they cross each other. So if you have a parabola, a line will go through it. Now here's the thing. It could be like this. They never meet. It could be like this, and just wait, meets one part. So you could have 2 solutions, 1 solution, or no solution. That's the catch. We don't know until we start doing it if it's going to have a solution. I would think that they wouldn't be that bad right now, but in theory, you'll see it. And by chapter 4, we're going to have so many tools to deal with this. So many tools to deal with this. So here we go. So here we have 3x plus y minus 2 equals to 0. So I'm going to go ahead and try to rewrite this into something that's more palatable. So here is y equals negative 3x plus 2. What form is that called again? Slope intercept form, right? Okay. So can I try to set these guys equal to each other right now? Maybe. To try and solve this? Well, no, I just want to find, this is a parabola. Like if I rewrote this as 4x squared minus 8x minus 3x plus 6. So we end up with y equals to 4x squared minus 11x plus 6. We have that. And now we can set them equal to each other. But look what happens, man. Look what happens. When I try to set them equal to each other, I just get something that I'm not really working with. I mean, I can work with it though. So look how it looks now when I set them equal to each other, because I'm trying to solve their points of intersection. So, yes. 16, right? Or is it 6? That would ruin everything, wouldn't it? So add the 3x, so we have 8x and then minus 2, right? So that's plus 4. So we have this. Can we solve that maybe? Factor out off a 4, x squared minus 8x plus 1. Wait, plus 2x, minus 2x, sorry. Plus 1. And then can we go ahead and factor this? X minus 2 times x. Oh, no. X minus 1 times x minus 1. You saw that? Is that true or not true? Is that true or not true? It is true.
Yeah.
-1 times -1 comes out to positive 2. And -1 plus -1 comes out to -2. Now, when is this true? When is that right? What does x have to equal there for this to be right? 1, because if you put 1 in here, wouldn't that come out to 0? Because 1 minus 1 is 0, 1 minus 1 is 0, 0 times 0 is 0. So that's the solution to that. Now, what's interesting there is that it has only one solution. 1. We call this a double root or repeated root. I wish I had like a tray here where I can have my mouse. Then it fell on the floor. Then I don't have a way to put on my legs, so let me fix it. Yeah, that's it. That's the solution. So, guys, don't put this on Instagram. The other day, there's a video of me standing on top of, or a picture of me standing on top of the desk at the media center. So, and nobody told me to flex or anything. That's rude. All right, so that is the solution, by the way. Now, how does this look? Here's what I want you to understand. So we go here to decimals. Guys, don't you think it's pretty cool this Microsoft Surface being used in class in this way while recording at the same time?
Yeah, pretty cool.
Oh, thank you.
Okay.
Oh, thank you. I'm glad you noticed. All right, so if we take a look at the original, it is. Were you being sarcastic?
No, I was not at all.
Oh, really? It is?
Yeah, it's pretty cool. It's helpful.
So you see, guys, she's enthusiastic. That's, oh wait, it has to be y. Y equals, well, the original question said what? What was the 3x what? What was the original curve? Y equals to 3x. Yeah, but the original ones. Like before I 3. Wait. For some reason, it doesn't sound right. Okay, I see. The second one, the 4x. The 4x. So give me that one first. So, because now I lost it there. Wait. So the 4x, what was it? There you go. That's the one I want. 4x minus 3. Oh my gosh, look where I put it. 4x minus 3. No! I just want minus, bro. Where's minus here? Where's minus? Well, plus, I'm gonna just go ahead plus -3 because this is not working fine. And then parentheses, what? What's the other one? 4x minus 3, what else? Okay, so x plus -2. Close it, right? And then the other one was y. Oh no, lowercase y. Y equals to. Wasn't it really weird looking though? All right, it was 3x plus y minus 2. Fine. 3x plus, oh my gosh. It has so many things over. So we have, oh my gosh, come on. 3x, what else? Plus y minus. I'm gonna go plus -2, and I'll put a 0 on the other side. All right, so here's what happens. Look how interesting this is. What answer did we get? We got -1, right? Now look, it only has one answer, and it crosses the parabola. Do you see that? -1, -1. And what was the answer? X equals to 1. That's the power of this. Make sense? All right, here's the problem with chapter 3. Chapter 3 feels like it's leading into chapter 4. So the real chapter we should be focusing on is 4, which is what we're doing. Correct. Good morning. I spoke with Al, A&F Construction, and he provided me with your number to call for swimming pools. I'm interested in a pool in my backyard. Would you be interested in building a pool? Be careful. Oh, Jebby, you were saying something. Go ahead. Basically, it's about functions. And then they focus a lot on this stuff towards the end of the chapter. So reality, we should be talking about chapter 4. Okay, but I'm still going to make sure that when I test you for chapter 3, you'll see the whatever I'm going to give you for a review, which we'll review next class, by the way, will be specifically in review for your quiz on Friday. Yes.
I have a question.
Go ahead.
When you were trying to figure out the intersections, you just said the both like points that they give you equal to each other?
Yes. So you said it y equals to something, something equal to each other and solve. But the thing that we're stuck right now, we're not really stuck. We're just, these problems have to be picked right now, handpicked, so you could figure out the answer. Because some of them don't have answers, but they're just trying to test you to see. So for instance, some of these questions here might ask you, I mean, look at number 10. Find a point where the line y equals 3 minus 4x meets that curve. Well, it's the same procedure we just did. But the thing is, you have very little tools right now to deal with this. So what I want to do is I want to go ahead and move ahead to chapter 4. And then we'll come back to this if necessary. I don't think it's too important that we delve on this until we have a full picture of all the tools that we have. Like, look at number 20, for example. Like, suggest a possible equation for each of the graphs below. Like, really? You know, yeah. In order for you to do that, you got to understand a little bit more about quadratics. Obviously, this is x squared, this is x squared, this is x squared, so something x squared. This is x to the third, x to the third. That's 1, 2, 3, 4, 5. This is x to the 6, and it's negative. But let's not even talk about that right now. Negative x to the 6, something. It could be more complex, right? But so let's go ahead and start chapter 4. I love chapter 4. Chapter 4 is the pivotal chapter. Chapter 4 tells me if you even have potential to pass the test at the end of the year. So here's what we gotta do. We gotta discuss something called completed the square. Okay. So the first concept we're going to discuss here is what is a quadratic? And in theory, you know this already. So I'm actually going to start a new set of notes for this, and I'm going to name them. So in general, a quadratic will come in this form. Ax squared plus bx plus c equals to y, I guess you could say. That's a quadratic. You could write 0 into it. That's when you're trying to solve for it. Specifically, you're trying to get the x-intercepts. So the x, b, and c are constants. All right. So that's quadratic. It's still resetting? Oh, we're almost done. So the main points they want to make about this right now, all right, they call A, B, and C the coefficients, and they call this the constant. So these are the coefficients. I don't know if it's 2f's or 1f's coefficient. 2f's coefficients, and this is the constant. All right, and the important thing about the quadratics is this guy here. The highest power is second power. That's what makes it a quadratic. Now, the first thing they want to discuss here is they want to discuss a property which is going to help us do something. It's called completing the square. The main motivation for completing the square is essentially, if I have this, x squared equals to 4, how do you solve that? You square root both sides, right?
Mhm.
And then what's your answer? X equals 2 plus or minus 2. Because -2 times -2 is 4, and 2 times 2 is 4. Now, the proper square root is always positive, but let's just leave that detail there. Now, similarly, if I gave you this, how would you solve that?
Write the parentheses twice.
You could do that, but couldn't you just take the square roots here? And once you take that square root, doesn't that kind of like cancel this out? But you gotta take both sides, right? Wait. And of course, I picked. Right, and then I just go x equals 1 plus or minus the square root of 8. You see what I did?
You can leave the 8 like that.
Yeah, I mean, it looks, unless it's a nice number, leave it like that. But you saw what I did there, right? No?
You
Yeah, I had to, because, yeah, I'm trying to get x equals to something. Let's try another one, because some of you look confused. Let's say I give you this. Let's say I give you x minus 1 squared equals the square root of 9. Sorry, not square root, 9, just to make it easy for you. So talk to me. I gotta get rid of the square. Like you suggested before to expand it, but there's no reason to expand it. We could just write there. We could just write square root of x minus 1 squared, right? Equals plus or minus the square root of 9. So that's x minus 1 equals plus or minus 3. So x equals 1 plus or minus 3. So now actually we can just write x equals 4 and x equals 2, negative 2. Because 1 minus 3 is, does that make sense?
Yeah.
Is over here, because I always feel like I'm talking to them the whole class, but it's because I'm angled. But anybody over here have a question? It's pretty good, right? So now remember what you just did right now here, without knowing what you solved was this. Here, this, you solved that. X squared minus 2x plus 1, you solved it right there. If I gave you this and you tried to solve it, you would have, you do this and then you're like, oh no, what's happening here? But then of course you remember from algebra that you go x minus 4 times x plus 2, and that's why you see the two answers are equivalent. What works there is 4 and negative 2. You see that? Now, what I wanted you to notice here is what happened right here. And I'm going to change it now to a more serious color because we're getting serious now. See this here, I'll write it back up here again. This first thing there, x squared minus 2x plus 1 equals to 9. There's something really important here that's happening. That if we take a look at it and we're careful and analyze it, will give us an extra tool. So obviously you can subtract the 9 and then factor and find the answer. But if we just take a little time here, we can say, okay, what happens when I do this? How does this look? Because if I tried to solve this, I can solve this right now. Straight up. Square root both sides, add the 2. X equals 2 plus or minus the square root of 3. I can solve that. And this is a quadratic. Because if I expand this, it looks like this. Does anybody need me to show them how I got that? I'll do it because some of you are new. X minus 2 times x minus 2, we FOIL. X squared minus 2x minus 2x plus 4. So that comes out to x squared minus 4x plus 4. You saw that? But I can rewrite this as x minus 2 squared. That is a very powerful tool. Very powerful. Because it's one of the ways, in fact, it is the way to solve quadratics. That knowledge right there. So let's talk about this here. Look at this here, this part here. I don't know, maybe when I hover around it doesn't do much. But if you look at x squared minus 4x plus 4, you look at this here, and what's half of negative 4? Negative 2. And what's negative 2 squared? Negative 2 squared. Negative 2 times negative 2 is 4. You see that? Well, that's obvious because when we did x minus 2, when we did x minus 2 here, when we did x minus 2 there, this, we squared it. But when we go ahead and FOIL it, this negative 2 becomes a negative 4. So the middle term comes out negative 4, and this comes out to positive 4 when you square it. So let's say I gave you the following. Obviously, this is a quadratic, but it doesn't have a constant in it. But let's say I wanted to write this and I wanted to be able to complete it square. What's half of negative 8? Negative 4. And there you go. Negative 4. So then what's negative 4 squared? So if I added 16 here, so half of negative 8 is negative 4. Negative 4 squared is 16. So now I can rewrite this as x minus 4 squared. That's called completing the squared. Why? Because I may want to utilize this to solve a problem. Let me show you what I mean. Let's say I gave you x squared minus 8x equals to 11. Like that. Now, how can I solve this? Well, one way is that method I just showed you. What you do is you say, what's half of negative 8? X? Well, just say negative 8, negative 4. Negative 4 squared is 16. So I add 16 here. But if I add 16 to the other side, did I change what this means? I added 16 here. Then I added 16 here. Did I change what this means? No, because I can just subtract 16 and everything goes back to where it was. All I did was make it look different. Because I added 16 here, I made this side a little bit heavier than that side. So I added 16 that side, so it balances out. It balances out. That's what the equation means. But then what this allows me to do is it allows me to rewrite this as x minus 4 squared equals to 27. And I can solve that. That's why we complete the squared. So it's a great question. The way I got 16 is I completed the squared. I took half of negative 8 in the motivation. You squared it. Yes. And the reason you're doing that is you're trying to take advantage of all the stuff I was explaining before. And now you can solve that. Because we just finished solving equations like that. You wouldn't, right now, you don't have enough tools to have solved this initially as x squared minus 8x minus 11 equals to 0. You don't have that tool. But by completing the squared, you can solve this. It's going to be, obviously, x equals 4 plus or minus the square root of 27. That's your answer. That is your answer. Completing the square is all you need to solve quadratics. Do you want to try another one? Okay, let's do another one. I know this is, but once you understand it, you won't have to worry about it ever again. Let's try another one here. I'm picking obviously nice numbers. I'm not gonna pick horrible numbers. So let's say you have x squared minus 10x. Let's do plus. Just make it different. No, let's do minus. Plus equals to 3. So if you had to solve this normally, you had to subtract the 3 equals 0, then you get stuck. You're stuck unless you can factor. And it's not factorable. Right? So we say, what's half of 10? What's 5 squared?
25.
But if I add 25 to one side, I have to add 25 to the other. So now it's balanced. So now we have x plus 5 squared. Because I completed it squared, I can write it that way. If you want to check x plus 5 times x plus 5 does indeed come out to this. It does come out to that. See it? And now you can solve that. That's obviously. X equals -5 plus or minus the square root of 28. So we're solving quadratics already by being able to do that. So that is completing the square. That's how you solve quadratics. When does it become a little bit more difficult? It's when you don't have an x squared that starts with 1, because in this case, the coefficient here is 1. So I want to go ahead and show you something. Now, when I'm done with this, some of you will dislike me. But that's because you don't realize how important this is. How everything ties together. So let's say we write this in a standard way. Y equals to ax squared plus bx plus c. This is the way we write our quadratics, always. And let's say I wanted to solve this when y equals to 0. Usually that's how we solve quadratics. It's good? Yeah. Let me see. Now go into check the hard drive for the, check out it's mounted. It's empty, right? All right. You're gonna give it a name, the computer? Oh, you just Sander. All right, good. That's your computer. Plug everything of mine back in. Make sure my computer's working, and my monitor is working. There's your computer. Make sure you take the miniature keyboard with you too, as well. And all right, so here we go. Now, bear with me. This is gonna not be too happy for you. So here's our problem. We begin. I want to solve this. So therefore, I'm going to factor A. Look at this. See if you understand what I did. Let me do something before I do that. Sorry. Sorry, wonderful people. If you wrote that down, just one more change. I'm going to write the equal on the other side. I'm going to subtract C first. So I have this. So write this first though. Not lose it, not, take a picture of it just in case you do lose it, so you can replace it, but it's gonna be tough. All right, so now I'm gonna factor out an A. Take care, man. You saw what I did there? See it? So you can factor anything. You just have to make it look ugly. Because when I that looks like a 9. When you multiply A times here, it's just B. Got it? Now, TV, I'm trying to solve for X here, okay? So now I'm gonna divide both sides by A. Because I gotta get rid of that A. So I'm gonna have X plus B over A X equals to negative C over A. You see that? Do you see what I did there? Now, this guy here looks like everything I was just doing, right? With the x squared plus 10x. This is exactly like the questions we were working on over here, where we started with x squared plus 10x equals some number. X squared plus whatever x equals some number. Forget it's b over a and all that nonsense. That's a number. B over A is a number, and C over A is a number. Pick B, pick A, pick C, and then you get those numbers. So now we said, hey guys, what's the number in front of the X gonna be? B over A. So I'll go, okay, I say to myself, B over A divided by 2 is B over 2A. And then I take B over 2A and square it. And that's B squared over 4A squared. Right? So I go, I'm completing my square, x squared plus b over ax plus b squared over 4a squared equals to, and I got to add that b squared over 4a squared to the other side too, b squared over 4a squared minus c over a. But now this guy here, I get to write him as following. I can just for short say this is x plus b over 2a squared. This whole thing is just x plus b over 2a squared. And then this here, now I gotta manipulate this guy here, and I'll just write them out here. B squared minus c over 4a squared, like that. You got a times b squared, that's ab squared, minus 4a squared c divided by 4a to the third, because that's crisscross happy face. And then I'm going to go ahead and say, oh, okay, this is factor out an a, b squared minus 4ac all over 4a to the third. But then one of these a to the thirds cancels, so it's b squared minus 4ac all over 4a squared. So now this side has become b squared minus 4ac all over 4a squared. But now I square root both sides. So I take the square root of this side. That's okay if you're lost. And then I plus or minus the square root of b squared minus 4ac all over 4a squared. So now this side is x plus b over 2a plus or minus the numerator is just b squared minus 4ac, and now it becomes 2a, and then I'm going to subtract x negative b over, that's why I told you you're going to hate me, negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, but then now you have your quadratic formula, which is negative b plus or minus b squared minus 4ac all over 2a. The quadratic formula is simply the result of completing the square. That's all it is. It's all it ever will be. And you just memorize it. Oh no, change colors. No.
What I'm trying to say is the quadratic formula is the result of us just completing the square. The quadratic formula, that stuff that you were asked to memorize, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the result of you just executing, completing the square. That's all you ever had. That's all you will ever have. It's the same thing. This is the result. The ugliest part here is this part. Come on, move. Is the part here where it's looking ugly. But this is like, if all I do right now is I begin this question. Look, if I began the question right now from the top here, but instead of having an A there, I write something like this, 3x, let me just keep it simple for now. X squared minus 4x plus 5 equals 0. Then the quadrat, what I did right now was this. I went x squared minus 4x equals to negative 5. That's the first step. All right, the next step, I did the A stuff there because I had a number, but here the A stuff, the A there is 1, but I'm keeping it simple. That's the hardest part right there, the A part. Okay, and later on, and then we went, okay, so then we went down here. We went here. And I asked you, so now this here looks like that. Doesn't it look the same? Doesn't this look the same? X squared, in this case is minus, plus some number x equals some other number on the other side. And I said, what's half of this number here? B over A divided by 2. What's half of it? Isn't this here half of that? So if I take negative 4 and I divide it by 2, wouldn't it be negative 2? And negative 2 squared is? So now I take x squared minus 4x plus 4, and then I do 4, I'm gonna write it nicely. Negative 4 plus 4. You see, that's all that's happening. All that's happening here. All that's happening here is that. The only thing I'm doing here is making it like look prettier. Like this stuff that happened here became this. But here, this here is this. It's negative 1. Yeah, that's all it is. That's all this is. In this case. And then this side here, I get to write as x minus 2 squared. That's this. And that's square root both sides. And guess what happens here? In this case, there's no solution because there's no negative 1. There's no square root of negative 1. We have no solution. That's how we know there's no solution. Yes.
So all of that is just a representation of everything we did before.
Yeah.
With letters. That's why it looks that weird.
Yes, it looks weird because you guys are intimidated by the letters, but it's the same thing. But if you understand this, definitely you're not gonna get a bad grade on your test. You're gonna ace it. It only takes a few hours. It's 2 hours. No, I'm serious. All it takes for you is to know what's happening. That's all. It really is. Remember, what one idiot can do, so can another. I need you to understand that. That is true. That is true. This is running out of battery. Let me see how much battery I got. Yes. What? But don't worry about it. Wait till I quiz you on it. But do you understand quadratic formula? Can you memorize it? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you understand the process of completing the square? Okay, so let's. Well, you got to make it. You got to force it. Let me give you another example. Well, you saw how I did this one here, right? What's half of negative 4? And negative 2 squared.
Got it? All right, let's try a more difficult one, but I always have to keep, I want to make things easy enough for you. So I gotta be careful how I pick things because some of them are hard to solve. So let's try another one. We're gonna go 2x minus 6x equals to 15. It should work. Yeah, 2x squared. Now, we're going to complete the square. This one makes it a little bit more difficult. Okay. How can we complete the square here? Well, in theory, I would have to go 2 parentheses x. Let me make this an 8, guys. Let me make this an 8. There's a reason I'm making it an 8. Make the middle one instead of -6, -8.
You said
Yeah, so let's make it to -8, -8. 2x squared minus 4x equal to 15. So I ask you, what is half of -4? -2. And -2 squared is? -2 squared is 4.
bro, I'm moving. So you're doing a little from the b over 2 to this.
Yes.
Papi, y póngalo ahí, y luego ya.
All right. So you see that?
Yeah.
8.
Why 8? Yeah, why 8? Oh, okay, times 2 times 2. Oh, I remember. Okay.
This is super important. You didn't add 4 to it. You added 8 to everything. Because when you wrote that 4 there, in reality, what you did is this: 2x squared minus 8x plus 8. So now it's 15 plus 8. So this now can be rewritten as what? Now here's the catch. See, and I want you to see patterns here. So we're following the procedures. This was 2 times x minus 2 times x minus 2. But now we have 2x squared minus 8x plus 8. We got to write it in completing the square form. So how do you do that? Say again? 2 parentheses. I don't know if that works for me. So did we complete the square? Yes. But there's always a catch. Right? How can you rewrite this? Because you're going to write this like this, right? You have to do that.
Yeah.
But could you have seen that from the beginning? No. You had to break it apart. So if I gave you this here, the way you would see that is by factoring the 2 out. Now, let me show you the power of this. So we said already that x equals to -b plus or minus the square root of b squared minus 4ac all over 2a. Do you agree that we already said that?
Yes.
Now, let me just quickly solve this. This comes out to x equals +2 plus or minus the square root of 23 over 2. Agreed? We could rationalize that if you want to, but that's the answer you get if you go through all this trouble. So you divide everything by 2 first, then you square root both sides, then you add the 2 over. Does that make sense?
Mister, what happened to the 8 when you did the 2x squared minus 8x plus 8? What happened to the 8x?
Yeah, because when you factor that, you get 2x minus 4 and x minus.
Yeah, you could factor it, but we don't, then it's not 2 squareds. We can't take advantage of this. we can't square root that because then we have, so, okay, I see what you're saying. So you guys are saying this is 2x and x, right? Minus what? Right, that's true, but what we want to take advantage is we want to take advantage of this property here that we can just square root both sides, get rid of the square so we can solve for x. Here you can't do that. You would have to find 0 for it.
What do? You leave out the 8x?
No, it's here. It's already here. Like x minus 2. This times this has the 8x in there. It's already here. It's just I'm leaving it this way so I can take advantage of square rooting. So remember, I'm leaving it that way. The reason I don't work with this here is I have this now in a beautiful form, so I can just divide both sides. Square root. And then add 2. Whereas if I try to do it, both Moore and Raman, if I try to do that with this, I'm stuck. Because now even set equal to 0. I would have to rewrite that set equal to 0 and see if it factors now to use that technique. But with this technique here, I can just go straight to, oh, it's just 2 plus or minus the square root of 23 over 2. But now, if I try to do this problem using the quadratic formula, where I write, so here we have 2x squared minus 8x equals to 15. And I rearrange this and say, oh, that's 2x squared minus 8x minus 15 equals to 0. And a equals 2, and b equals -8, and c equals -15. I should be able to go x equals negative of -8 plus or minus the square root of -8 squared minus 4 times 2 times -15. Divide that all by 2 times 2. And I have x equals 8 plus or minus 64. That's going to come out positive. What's 15? -4 times 2 times -16. So 4 negative times 2 times 15 negative equals 120 minus 120. That's not good. Minus 120 is not good. Why is minus 120 not good? Because it gave me negative, and I got a solution to this. Did I write everything right? I did. I wrote everything perfectly right. Did I substitute everything perfectly right in there? Yes, I did. Minus 4 times a times c. That's correct. Did I complete the square there properly? Yes, I did. Lovely. 2x squared minus 4x. -2 squared, 4, 8. Yeah, that's right. Okay, when in doubt, look at your mistakes. Because right here, what does this tell me right here? You can't find the square root of that. And what is this called, by the way? Do you remember? Huh? Ah, thank you. There we go. Now I feel better. All right, by the way, that's called what? The discriminant. The discriminant will tell you so much information. It will tell you whether you have 2 solutions, 1 solution, or no solution. If the discriminant is 0, you have 1 solution. If the discriminant is positive like this one, you have 2 solutions. If the discriminant is negative, you have no solution. And we'll discuss that next class more in detail. So we get 184. So we got x equals 8 plus or minus the square root of 184 divided by 4. Okay. And so now I'm supposed to break that down. I don't feel like breaking that down, but let's try it. 184, I got a feeling it divides by 4. It does. So we got 8 plus or minus the square root of 4 times the square root of 46, all divided by 4. I'm gonna break that down again. That's 8 plus or minus the square root of 4 times the square root of 23 times the square root of 2, all divided by 4. So that is going to break down to -8 plus or minus 2 square root of 23 times the square root of 2 over 4. So that's gonna be okay. So I'm gonna go ahead and I don't even want to factor it, but let me just put the 4 out here like that. Okay. You know what? Let me make it simpler. Up to you guys. I don't want to play around too much with the numbers. I'm gonna factor out a 2 times -4 plus or minus square root of 23 times the square root of 2. Do you see why chapter 2 is important? You know, like if you're not comfortable with that, so now you got -4 plus or minus, this becomes a 2 down here, square root of 23 times the square root of 2. Square root of 23 times the square root of 2, square root of 46. So square root of 46 over 2. And then simplify that, -2 plus or minus the square root of 46. I might have messed up somewhere, who knows? And that should be the answer. And then you look at this here, you're like, they're not the same answers, mister. And I'm like, well, I don't know. Maybe I should just kind of like rationalize this guy. Maybe it works. I'm not sure if it's going to work. But then if I messed up, I'll just go back and look at it. So what are you supposed to do here? Rationalize the denominator, right? So this comes out to 2 plus or minus the square root of 46 over 2. I'm sure here. So I came here, this answer came out to -2 plus or minus the square root of 46. And then now this answer is coming out a little bit different, but it's possibly because I'm being a little bit sloppy somewhere, usually. But it's square root of 46 over 2. So it's saying 1 plus or minus the square root of 46. So therefore, wait, -1. So I got a 2 there. I don't know why it's a 2. It should be the same. Oh, I know why. Because this came out here. -2 minus 4, but that's fine. This was not negative. This 8 here, this 8 here wasn't negative. And for some reason I made it negative there. Why on earth did I do that? I wrote it here. Here's where the mistake happened. You see it? So this will be positive. Okay. And then, so 2 times 4 plus or minus, there's a 1 here. I'll write it. And then, so this is positive. All right. So that's a little bit better. Not much, but a little bit better. And then 4 plus or minus the square root of 23. 2. Okay. And so why is this frozen now? I have to restart this. Only be careful. Come on, computer, hurry up. Ooh. And how much battery do I have? I have 18%. I got enough to finish up this. Come on, computer. So yeah, your homework's going to be completing the square, okay? And plus I'm going to attach all those things there. And then we'll do quadratic again. Don't worry. Don't stress. It's not that hard. You'll be fine. Okay, so let's see here. So make sure I did everything here. Correcto mundo. Yes, 46. 2, good. And then this is going to be plus 2 plus the square root of 23, which that's fine. And then this guy here, when I started playing around with all these numbers here, it looks good. It looks good. Yes, I factor out of 2. 2, 4 plus 2 to do good. And then that causes this guy to become a 2 on the bottom. But then when I do that, the square root stuff, this is fine. It works fine. 2 times 2, 4. -2 plus or minus. I have a discrepancy here. I don't like it. Oh, well. Nothing's perfect. Oh, I know. There's no discrepancy. Well, there is a discrepancy, but then it goes on to this one. All right, there's a discrepancy, but they should be the same. Okay. There must be a small arithmetic mistake somewhere. It has to be here. So let's go here. 8 plus or minus 46 times 4. Good. So it's going to be, instead of me being so dumb here, let's go here. 8 plus or minus 2 square root of 46 over 4. Is the math correct there? Yes. So 2 plus or minus the square root of 46. So that's what it's supposed to do. That's what it's supposed to be. Square root of, that's it. That's the answer. But then the 2 stays here. There we go. That's better. Because when I do it that way, so here I have this. 8 plus or minus 2 square root of 46. So let's say I factor out a 2. You get 4 plus or minus the square root of 46 divided by 4. So that causes this to just be 4 plus or minus the square root of 46 over 2. Then this is 2 plus the square root of 46. So when I go up here, so I'm here, and it's almost time to leave, I know. So now let's analyze this here. We got 2 plus or minus the square root of 23 over 2. This becomes square root of 3 over 2 is square root of 23 divided by the square root of 2, which is the square root of 46 divided by 2. So it's 2 plus or minus, there it is, square root of 46 divided by 2. So that's, if we do crisscross happy face, 4 plus or minus the square root of 46 divided by 2, it comes out the same. Now it's fixed. Yay! There. So now we have the same one. All right. So what was it today? One way we solve it using completing the square. And the other way we use the quadratic formula. But they're the same thing. They're the same thing. So what I'm going to put for homework for 4A is basically working, because if you look on this, on the book part, you notice that they spend an egregious amount of time going over completing the square. Okay. So they spend some time and they work with numbers that are not pretty. So for homework, I'm going to put there the numbers that are pretty and not pretty. And hopefully you have some questions for me so I can go over in class the manipulation so that we can move on to 4B, as well as go over the review I'm going to be posting on for chapter 3. Okay. Remember, what one idiot can do, so can another. Do you guys believe that? Yes, no, maybe? So I'm going to stop the share. I'm going to end it here.